This lesson is going to focus on the Week 2.1 patch that you can download, and please feel free to bring it up on your computer and follow along with this lesson. You should be able to do everything that I'm doing on your own version of the patch. So I've got this open, but what I want to do is I wanted to create just a new patch just to explore a couple of things first. And this patch is, I always go in and set up a nice style so we can see our objects a little more clearly. I'm going to put a plus 127.0 in here. I'm going to put a multiply object. I'm going to put a divide object, divide space 12.2, and I'm going to join these into my, actually I'm going to get rid of that, I don't need, I'm going to put a 0 point, just to, we'll see later on today that putting the 0 point just ensures that this is a floating point addition. I've got a multiplication going into the first inlet, a division going into the second inlet, an F for a float box coming out of this so we can see our result. And then I'm going to do something a little bit strange. I'm going to put a value of 45.3 and I'm going to attach it to two places. Now, Max has got a decision to make here because I'm sending a value of 45.3 from a message box to two different places. It's going in here to be part of a division, and it's going here to be part of a multiplication. And then those, in a sense, are going on into this addition. So Max has got to make a decision. And so what Max has decided is that it is going to perform the operation. When an object is going to more than one place, it will go to the place that is to the right physically on the patch before it goes to the left. If you have objects that are in the same XY location or same X location, it will go to the object that is further down on the page before it goes to the object that is higher up on the page. Okay. So let's put our, I'm going to select those two and I'm going to enable the debugger and put a breakpoints in there so we can see what happens. So I'm going to click on this, and what we see is this happens, that goes down there, this value is now set, this comes down there, that comes down there, and the answer is calculated. So that's fine. 58. I'm going to change this to something else. 1.3. And I'm going to move it over here. Now what happens when I press this? That happens first. The answer happens, and then this calculation gets stuffed in here, and nothing, it's not actually used. So the calculation I get is not actually using the division 1.3 in here. It's using whatever was currently in there from before. In other words, the previous calculation that I had is in there. Now when I click it again, the answer I just got was 58.04. I click this again. And now I get a different answer. Okay. So you can see that this is a problem, or potentially a problem. And I've had patches before, not my patches, but other people's patches, where suddenly things stopped working properly. And it had to do with the fact that an object got moved physically on the page, and that movement caused an order of operation to be messed up. Something was not where it was supposed to be early enough that it could be used. And you can see that this can happen quite easily if you're moving objects around on the page. So we don't want that. Don't save that. And so here's golden rule number 1 for Max MSP, Music 320, golden rule number 1. I'm going to zoom in a little bit just to make things easier. Golden rule number 1 is that you use a trigger to explicitly control the order of messaging whenever you're sending data from an outlet to more than one inlet. And here's exactly what we were seeing in that other example. If I click on this, I get that answer. If I click on this, I get a different answer. And the reason is simply because the calculation is being performed before the value has been put in the into the right inlet. Right? So how do we combat that? How do we make sure that this doesn't happen, that moving objects on the page will not cause different results? We use a trigger. And I'm going to scroll over here, and we can see how triggers work. Essentially what a trigger does, it allows you to output, so you can specify the kinds of values you want outputted, and the values will be output from right to left. So this is the first object we've come across which is going to have a variable number of outlets. This, when I type trigger space BIIFB, what I'm saying is I want to trigger a bang, well I do it back, a bang, a float, an int, and a bang, in that order and with those types of outlets, those types of data types coming out of them. So the trigger has, in a sense, a built-in casting property where you can convert the data type from one to another, as long as it makes sense to convert it. Obviously, integers can be converted to floats, and floats can be converted to integers, and anything can be converted to a bang. All right, so I'll make a new trigger. By the way, why don't I just use the shortcut? Trigger's used so often that the shortcut is just T. So TII would be a way of triggering 2 integers. I'm going to change this to a different, I like blue better. So very simply, if I just hook this up with some integer boxes, all that's really happening is that my value of 12 comes in as an integer, and it goes out first the right outlet, second outlet, then the first outlet, so I can be sure that I'm going to get the correct values going in the correct order. Okay, so if I wanted to go over here and fix this, what I would do, move that out of the way, is I would make some space and I would go trigger II, right? And then I can attach these like this in order, and then it doesn't matter where this object is. This object can move over here, right? Move anywhere, because the trigger is actually making sure that this one is going to be done first and this one is going to be done second. Okay, so I would say that even though at first it doesn't look like this could possibly be a harm, not using a trigger, I have this sort of rule that whenever I'm sending something to more than one place, I'm going to use a trigger. Even if it's a simple trigger, which is trigger B, 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 to send 8 bangs to different places, I want to make sure that I can control the order. So this is a way of forcing an ordering. All right, so let's zoom back out a little bit so we can see what this is doing. So when I put a value in here, it's actually a floating point number box, so I'm going to put a floating point number. The first thing that happens then is a bang is sent here, and the bang is going to go into this make note, and this make note is going to play. Now this make note doesn't have any arguments. So in fact, when I do this, I'm not going to hear anything, because a velocity of 0 and a duration of 0 is not going to produce any notes. Right? So I could do that and we'll hear nothing, or you can just take my word for it. As soon as I do something like this and put a note in, I now have supplied it with default with values, a velocity of 40 and a duration of 1,000. Okay, then getting back here, so there was a bang going into a message box. Then I had a floating point number here, and so the floating point number will be passed here. Then I have an integer, and that integer will go here and do a make note. And then I have another integer, and this integer will go in here and will be put into this addition box. And then finally another integer will come out here. Actually a bang will come out here, bang the 120, which goes in here. We added to that and gives me a result. So I'm going to put in a value of 60.12. Now, what did I hear? I heard the note 60 because this was forced into being an integer by the trigger. And so if I want to, I'm going to type I to put a number box in. I'm going to hold the shift key down. This is something new in Max 8, where if you hold the shift key down, you drag it into a patch cord, it'll insert it in the middle of the patch cord. So I'm going to do that again. I'm going to type 61.23. We're hearing the 72, which is banged, and we're hearing the 61. All right, so trigger has this sort of dual function of being able to control the order in which messages are sent and being able to do this casting or converting to message types. As well, if you need to, you can actually force specific values in trigger. So, this may seem like it's a bit silly. Well, not really silly. But if I always wanted a value of 12 to come out a particular outlet, I can do that. And whatever is put in here, this outlet will put out a 12. So I'm going to put in 48, and 12 comes out there. Right? So you can force not just types, converting types from integers to floats, floats to bangs, bangs to integers, and so on. You can also specify that I want a value specifically of 12 to come out of a particular outlet. Okay? So remembering that when you use a trigger, the actions outputs are going to go from the rightmost outlet to the leftmost outlet, one at a time. Okay? So those are triggers. Please use them. I'll put this back. And we're going to look at math operators. And you will need math operators for your first assignment. Now, one thing that's very important in Max MSP is that we must be conscious of whether we're dealing with integers or flow nums. Integers are floating point numbers. And so when we create one of the math operators, which are division, plus, multiplication, and subtraction, those are the main ones, remembering always to put a space before we supply it with an argument, there is a difference between saying divide by 6 and saying divide by 6 decimal. When you put the decimal in here, it creates a floating point division object, which is capable of doing high precision. When you do not put a decimal point in here, then you are creating an integer math operator. And it will truncate any kinds of floating point numbers or decimal points that get created. Okay? So there are potentially problems, what we would call rounding problems, that occur. So here down at the bottom here, you can see that what I have done is I have an integer coming in into a division of 5 point. In both cases, I'm using a trigger. I'm passing an integer to both of them. And then here, on the left side, I have a floating point number box, and here I have an integer number box. And then I have an addition, which is also floating point because it's got a decimal, and that's going into a floating point number box at the bottom. When I click on this 12, I'm going to have to move my patch up so you can see. When I click on this 12, I do not get the same answers. And when we look through this, we'll see that the reason is that if I'm dealing with floating point numbers and anywhere in my chain of calculations I have an integer, I am going to truncate the results. So 12 divided by 5 is actually 2.4, but when I put it into an integer box, it becomes 2 because integer boxes can't deal with decimal points. And then once it's been truncated to 2 and I add 1.23 to it, the answer I get is 3.23, not the correct answer of 3.63. So you can see you have to be very careful. It's very easy to make this mistake. I fixed someone's patch just yesterday who was working in the laptop orchestra, who for the life of him he couldn't figure out why his patch wasn't working, and it was because of an integer box in the middle of a calculation that was making the calculations incorrect. Okay, so if we go back up here and look at our math operators, I'm going to click on this 11. The 11 is going into a float box, and then it is triggering 2 floats. So this one is going first, and these are all flow-num calculations, and these are all integer calculations. And if we type number 11 in here, or pass number 11 into this, we find we get different results. And that's simply because the first thing we do is a division. And 11 divided by 6 is not an integer. It's a decimal, it has a decimal place, and so it's going to be truncated. And then when we add and multiply and divide, we're doing all of that to the wrong value. Try another one. Same thing. All right? This one has been truncated because we're dealing with integers, and this one has not been truncated, and this is actually the correct answer. Okay, so it's very important. Just be aware that when you put plus and just leave it, this is an integer operator. If you put plus 0 point or anything point, this is a floating point number operator. Okay, so I can put a 0 in there. It's very important that you make this distinction, because if you just put the operator without any argument, and the argument does not have a decimal point in it, then it will default to being an integer operator. And you'll find that when you start doing, for example, in your first assignment, doing calculations on currency, that the bank will not be happy. Your customers will not be happy when you truncate all of their cents in your calculations. So this is something that it's easy to make this mistake, but now that we've harped on it, you won't make that mistake. Okay? And all of these operators, all of the basic math operators work the same way. They have an inlet which will alter the value that is being operated with, and then basically will replace your default value, and then the first inlet causes the action to actually take place. Okay, so they all work the same way. We could put values in here and alter so it's not divided by 6, it's divided by something else. Okay, now once we have indicated that this is a floating point number box, because we created it, when we created it, it was a floating point number box, we can actually put an integer in here and it will still treat it as a floating point calculation. So if we put an integer 8, it doesn't change this object to being a non-floating point object. That gets specified when the object gets created. Hope that's clear. Okay? And finally, in this week, I just wanted to introduce the mod operator, because it's an operator that those of you who have done computer science will have come across. Some of you who have studied music theory may have come across it as well, but it's not a commonly used operator. And the mod operation works with, at least in Max, it works with integers and provides you with the remainder of a division. So mod 12 essentially means if we divide this number by 12, what is the integer remainder that results from that? Right? So if I put in a value of 60, for example, well, 60 divides by 12 evenly, so the remainder is 0. But if I put 61 in, or 62, I get a remainder of 2. And I go up to 72 is 0. 73 divided by 12 gives me a remainder of 1. So this is a way of sort of calculating remainders. It's very often used with pitch classes. So you might have already noticed that, because it's doing 12, that middle C is 60 and 59 is a B, or pitch number 11, and 58 is a B flat, or pitch number 10. So I can actually use this to calculate pitch classes in Max. Right? If I wanted to know whether it's a C sharp or not, I can do a mod 12 and see if it's equal to 1, because no matter what pitch it is, if I do a mod 12, if it is 1 over the division of 12, then if the remainder is 1, then it will be a C sharp. Hope that makes sense. A useful little tool to know about. So that's really all of the objects you're going to need to deal with for the first assignment, which is due at the end of week 2. Just be very careful about these math operators, the numerical operators, and make sure that you are using floating point numbers in your calculations, because if you don't use floating point numbers, you're not going to be getting the accuracy that you need. Okay, thank you.